We will examine digital treatment of full mouth for natural teeth by explaining an actual case. Natural teeth or implant retained prosthetics always required basic aesthetic analysis, which we'll briefly discuss later. Additionally, there are cases where there is either too little or too much space, especially for one dentition, which can be very challenging. In many cases, extrusion of teeth occurs to the extent when they are worn. Additional treatment of hard and softer tissue is required. For full mouth treatment, overall harmony is crucial. Restoring one dentition often requires treatment of teeth, bones, and gums to match overall harmony. Various criteria are necessary for this, and it is essential to use the references to establish a proper treatment plan. Various criteria may include tooth access, mid-line, and tooth ratio. The way concretized diagnosis is a mock-up. This is analog mock-up using silicon index. It helps communication with the patient and enhances the dentist's understanding of treatment, also aiding in minimal tooth reduction. This is digital mockup. Mockup can be produced immediately through the printing or milling after digital diagnostic workshop. And you can add stain glazing. This process increases patient understanding and consent rate and give an idea. The first processing build prosthetics such as staining and glazing. The main issue with one dentition is the problem of vertical dimension. Since the eruption compensates for the amount of wear, raising vertical dimension can be risky. The best plan must be made of combining information from the face, swallowing, and pronunciation. I think one of the advantages of digital treatment is that you can send files to colleagues far away and carry out a co-op project. I sent it to Germany. Recently, affordable facial scanner have been available, which is very helpful in clinical practice. Please keep in mind that the texture can make the scan file appear better than the actual property. In this case, the required accuracy for alignment is slightly lower, but it is aligned accurately enough with the oral scan. The reference planes of remaining dentition can be set and reflected in the treatment plan. We can get facial information such as midline and occlusal plane. We can determine occlusal plane using facial scan with campus plane. Be careful as it can look different depending on the graphical projection in CAD or other 3D software. This should be considered in smart design and using 2D photo. The patient expressed satisfaction with the mock-up shown earlier, and the crown lengthening procedure was performed to reduce the amount of vertical dimension increase. A template was produced like this to accurately transfer the amount of length reduction from the mock-up to the surgery. These are initial photos and mock-up photos. Mock-up was done using 3D printing and silicone index from the diagnostic model. The restoration was completed using biocopy channel based on the same-day digital chairside diagnostic model. The posterior part was finished first, followed by anterior part. In 1 week check photo after treatment, you can see the well-healed interdental papilla between the maxillary central incisors. During the process determining the tooth color, milling some parts in advance allows check the direct milling result. Although patient request was for slightly brighter and more opaque color, it is also helpful for long-term color stability. While dentures themselves are an option for treating full edentulous patients, they can be a starting point of the full mouth implant treatment. One of the most important points when making a surgical guide and using it in surgery is that the dental cavity must be taken at the originally planned position. If not, the surgery will be very inaccurate. It can be very dangerous. This can create huge errors, so you should be very careful to denture stability during taking CBCT. For digital dentures, using silicone impression material for proper functional impression is recommended. Stability, retention, and occlusion must be well understood before making digital denture. Recently, I have been using Ivoclar version on integrated product. Using UTS CAD, the position of maxilla is determined. Various angles and values can be adjusted, just like the actual model. Using 3D bite plate, the virtual dimension is modified, and moreover, the horizontal position is determined through body arch tracing. As mentioned earlier, parametric library is very convenient for digital libraries. You can achieve the harmony with the minimal manipulations. Please set the posterior part first and adjust mandible anterior part slightly. This is the final milling result. Next is a stock abutment library used for temporary or final prosthesis production after surgery. If possible, to adjust the angle between implant when making a guide, stock abutment can be used. This reduces the time required for custom abutment processing. The surgery was performed using the guide, often flap was down due to insufficient attached gingiva. The temporary prosthesis is made using the scan body and library for stock abutment after surgery. This is the same way using TI base or MUA cylinder. Occlusion was increased using a vertical articulator, and orthodontic treatment was performed using bracket only the mandibular anterior teeth. Fortunately, with the proper posterior support, the maxillary anterior teeth naturally returned to their original position. The patient adapted well to the temporary teeth during orthodontic treatment was satisfied. The treatment was completed by changing the material from PMMA to zirconia without any design changes. The occlusal points shown here are the unadjusted appearance just after setting. A slight adjustment was needed in this case. Let's learn about Oronex, which is widely used in full mouth implant treatment. Sometimes the prosthetic part used in this treatment can feel quite complicated. It is important to understand the purpose of each part accurately before starting the case. To simplify, an MUA is connected to the implant fixture to provide a favorable angle for multi-unit restoration, and abutment level impressions are taken using scan bodies. Traditional cylinder or temporary cylinder can be used afterward. The temporary type of 2mm depth is quite useful due to its very convenient manipulation. As explained earlier, existing analog compensate can also be digitized and used. Surgery was performed using conventional edentulous digital guide. The oral scan was done at the MUA abutment level. When the scan's precision or alignment accuracy is considered insufficient, a focal library is useful. Previously, focus were performed using a bar at the expected fixture location. We no longer need to drill holes inside using a bar, making it very convenient. Cleaning excess resin cement during MUA cylinder cementation is always tricky, but this type of temporary abutment makes cementation process much easier. Additionally, it provides another opportunity to take precise impressions. When prostheses are designed subgingivally and 2mm gingival height is very convenient. Snap it components are so advantageous for increasing convenience. When fix the metal cylinder to the restoration, you can use the cotton long to remove excess resin easily. Using packable lacquering resin can be used for intraoral cementation. Look at the hole in the sideway. You can feel the recurring flow legend. That is very convenient to achieve the stable cementation. I prefer non-cylinder type temporary restoration for MUA. It saves time and it's more convenient because there's no need to use cement. However, it must be made with a high precision, even if such as PMMA fits without much difficulty. It is not guaranteed to fit when made in metal frame in the same way. Let's look at the 5-year follow-up of oral neck treatment using MUA. Despite of our best effort, what happens if there is a misfit? Within the tolerance range, there may be no clinical complication, but too large misfit can create internal stress and cause mechanical or biological complication. In the era of analog dentistry, the study Strong and Mish reported that using the best casting frameworks, movement from 3 to 8 micron occurred in D1 bone. Now let's discuss an interesting aspect of screw retained and cementation. Even when using the same system, that is the same component, the type and required precision level differ depending on the order of attachment. When you cement the cylinder or tie base first, then fix it with the screw, it becomes a screw retained prosthesis. To the contrary, if we screw the tie base custom attachment onto the mouse first and then cement it in intraoral environment, it becomes a cementation type. Generally, screw retained prosthesis require a higher level of precision. Using 8 implant and MUA in maxillar diagnosis, surgery, temporary prosthesis attachment, and final prosthesis attachment was performed. Because the maxilla can be scanned more accurately and conveniently than mandible, the entire process was carried out using only intraoral scanner. What happens if passive fit is not achieved? In some screws cannot be tightened or forced to be tightened during installation in the mouse. Misfit can cause zirconia cracks. Even if it fits well initially, frequent detachment of the cylinder may be experienced. This is a 5-year checkup of above case. During that time, the patient did not experience any discomfort such as screw loosening and resin detachment from the screw channel, and the bone around the implant remains well preserved. All screws were checked for loosening torque. There were no detachment of the cylinder or loosening of a screw observed anywhere. There was slight food infection. If possible, we should make a convex subgingival shave. How to ensure passive fit? You must clearly understand the scanner's capability and limitation. The type of prosthesis must be actively determined according to level of precision expected. If necessary, analog correction should be used in this case. Minimizing errors to achieve accurate final prosthesis is always important. At this stage, it is essential to clearly understand the reason for the error, and separating and analyzing each step is crucial. There is often a tendency to focus heavily on the accuracy of the scanner. Errors come throughout the entire treatment and prosthesis manufacturing process. Numerous errors can occur, such as scan body distortion, improper attachment of the scan body, processing errors of the scan body itself, mismatch between library and the scan body, and milling errors and deformation occurring during sintering. I conducted a study with my colleagues focusing on the process of aligning scan body in the CAD. Even if the scan body itself is accurately processed and scanned, serious errors can occur if there is a problem with aligning them. Therefore, it is very important to make the alignment easy and accurate. We can modify digital library to improve this. An alignment error of 20 to 30 micron may seem clinically insignificant or negligible, but in the case of multiple implant, angular issues can amplify the error more than expected, affecting the fit of the prosthesis. Remember that the three-dimensional position of the platform is important, but directional misalignment can create even larger errors. The next part is about milling. Many clinicians make custom abutments and then attach them into the mouse and rescan, but I generally think it's better to produce lower abutment and the upper crown and bridge simultaneously. To understand the manufacturing method and accuracy, it's good to study more about CNC milling and dental 5-axis milling machines. We further examined what these custom abutment and restoration are in the correct position when attached to the mouse. Through this analysis process, we can identify where errors occurs and decide on the manufacturing method. To achieve perfect fit, overall process must be accurate. Scan body itself, library, alignment and milling is important. You should check each abutment in internal fitting before you set the entire bridge setting. This is final prosthesis. Next, briefly look at the virtual articulator. Recently, there are devices that electronically record jaw movements, and some scanners have such functions. However, average mounting is still useful. The guidance of the design teeth themselves has more influence than the human condyle guidance. Although factors such as the periodontal ligament and the flexibility of the mandible have an impact, the virtual articulator is very useful, and using it well can minimize the adjustment time in the mouse. To improve masticatory efficiency, focusing on small movements, especially side shift rather than large movement of the virtual articulator, can be a helpful tip to observe dynamic occlusal point. For tooth-supported guide, there are few variables to consider, but for making fully edentulous guide, various options can be considered. Guides can be used for bone reduction surgery and implant surgery, or as a scan template to improve scan accuracy. Each of these guides can be made separately. Alternatively, one could keep the lower part fixed and change the upper part for series of tasks. Let's briefly look at the case. In this patient case, the maxillary teeth are all scheduled for extraction and the lower vertical dimension is problem. Diagnosis must be thoroughly prepared in advance. In this case, since the remaining maxillary teeth needed to be extracted and attention must be paid to the mobility of the remaining teeth and the matching of CBCT and intraoral scans. We must envision the final prosthesis in advance. The vertical dimension was increased to match the expected final prosthesis using virtual articulator. The first guide is for anchoring pin drilling. The remaining teeth are used to align with the CBCT. The natural teeth was used as a last to serve as a drilling guide for anchor pin in the future guide. Anchor pins can have a thread for better fixation, but be careful as twisting may occur during fixation. Although complete denture can be made by replacing the denture in fully edentulous case, using pre-existing information allows CBCT and scan alignment. If there is tooth mobility, the palatal software tissue can also serve as a reference point, and moreover, you can use the flowable resin marker for alignment. Using transpersonal MIS implant fixture and MUA, an Oron 7 plan was made. It is crucial to incorporate the allowable angles of each part into surgical plan. In this case, only a straight type MUA was used. Guide program that support stackable guides can be used, but for simplicity, let's create one using mesh mixer. This is a workflow using stackable guide, anchor pin drilling guide, implant surgery guide, and restoration and scan template part. Combining them looks like this. The guide was printed using 3D printer. Sufficient rigidity is very important. For fun and identity, the digital lab analog of the ICMC company was used for the connection part. We can use the library with the non-metal sleeve in 3Shape in Dental CAD/CAM. This is assembly of move of the stackable guide, which can be used for immediate prosthetics and scan template. This is a video of drilling for anchor pin. On the right is process of checking the stability of the stackable guide for surgery. Let's look at the temporary restoration fabrication. After surgery, the MUA temporary cylinder is mounted in the mouth. The restoration part is assembly to complete the temporary prosthetics by filling the last with the legend. The last is done outside the mouth by removing the cylinder screw. The completed prosthetics is shown on the right. The lower anchor part can be used as a scan template. If the scan bar is slender like a cylinder, the surgery has been performed accurately according to the original plan. Surgical guide can be inserted and scanned. Although the most implant was matched accurately, some were aligned within 5 to 10 micron deviation. At this time, you can use area-based local best fit alignment. This is the CAD design process of the prosthetics. The key point is that if alignment is done correctly, the temporary prosthetics can be designed without much effort according to the restoration plan for surgery. The PMMA temporary prosthetics was made according to the first CAD design. Please note that the position of the screw hole, the remaining wall thickness, and the thickness of the support for screw can slightly impact durability. Finally, we can brief the answer question from this lecture. The question 1 and 3, we learned that the effective diagnosis, we can acquire facial information and set various reference planes, especially the occlusal plane and the midline are important. Gothic arch can be used for horizontal positioning, while the beauty of individual teeth is important. We can pursue efficiency by understanding the standards for aesthetic treatment and adopting digital libraries that reflect these standards well. For question 2, the precision of scan body is crucial. We learned the importance of using shortcut scan and scan template. Also, it is important to choose or tune library with good compatibility. For number 4, creating dental prosthetics is like learning a factory to make a perfect product from design to the final product. By analyzing and correcting the problem that occur at each stage, you can solve various issues and achieve your desired goal more safe and easily. Thank you for listening, and I hope my lecture has been some help in your clinical practice. I look forward to the opportunity to meet again. Thank you.